To simplify an expression containing a radical, we begin by noting what the index value is, because this will determine our first step. In this case, because it's a 3, we will begin by attempting to factor into cubes. Factoring into cubes means that we will look at each factor in the term 125 is a perfect cube root, can be written as 5 cubed. Looking at our next base, m to the 30th power, we notice that the 30 is evenly divisible by 3, so that rewriting this as m to the 10th power, the quantity cubed, would seem natural. The challenge comes with noticing that the base of p is not divisible by 3. So we look at it as a product where we have removed p squared to its separate term, so that p to the 18th power could be written as 6 p to the 6th to the 3rd power. Our next step is to recall the product property of radicals, which allows us to then write this multiplication as separate radicals. We can then recall that the cube root of 5 to the cube power can be rewritten. Applying that product property individually, then the cube root of a cube is the base itself. This also applies as we look at the base of m to the 10th. That cube rooted would be m to the 10th. That is also why we were dividing the p into separate terms, because the p to the 6th is a perfect cube, so we can write that now as p to the 6th, but the term, the cube root of p squared, is as simple as it can be written. It needs to remain under the cube root as a p squared term. This expression then is our answer. 5 m to the 10th power p to the 6th and the cube root of p squared.